This is Precalc concept 35B. We're going to look at a couple word problems involving law of sines. Law of cosines, excuse me. But before we do so, we're going to talk about an idea that some of you may be familiar with, but many of you may not, and that's the idea of bearing. So if you've ever been around a pilot or someone navigating a ship, you probably have heard or understand this concept, but if you haven't, you may not. So basically the bearing is simply a direction in which you would travel. So let's start off with some basics. If you are looking at a map, you are typically looking at north facing up, south facing down, east facing to the right, west facing to the left. And a bearing is simply going to be a measurement of an angle based on this, but it's very different than your unit circle, and so it's just important to kind of understand what some different bearings are. So I'm going to look at a specific example. If I did north 30 degrees east, right? So the way you want to interpret that is you want to point yourself north. I like to think of a dotted line that's a north-south line, so north at the top, south at the bottom, and you're right in the middle of that line. And which direction are you going to travel in? Well, you're going to face north, and then you're going to head off to the east by 30 degrees. And so on a map, you would travel in that direction where this angle right there is 30 degrees. Right? So in word problems, you want to kind of understand a description of bearing. Let's do another one. Let's do south 15 degrees west. Right? So put yourself on a map. Think about a north-south line. That was a bad line. Let's try that again. North-south line as a kind of an imaginary line, and you're going to take your location. You're going to point to the south, which would be down, and then you're going to spin off just 15 degrees west. So that would mean you would travel in this direction, 15 degrees. Okay, let's do one more. What about north 17 degrees east? Actually, let's do north 17 degrees west. Just as a slightly different example. Right? Okay, north-south line. Point yourself to the north, and you're going to spin off or point off in the 17-degree direction. All right? So you can imagine that allows you to kind of travel in different directions. If you're flying a plane or you're navigating a boat, you will often head out on a certain bearing, and that just tells you the direction in which you're traveling. Okay, so we're going to jump in with two word problems, and we're going to give you a crack at one. Here is a problem, and sometimes you'll have a picture provided, other times you have to come up with a picture, so I picked one where we've got to kind of think about the picture here. So here's what it says. Two ships leave a harbor at the same time. One ship travels on a bearing of south 12 degrees west. So let's kind of imagine our harbor as a point. And if I went south 12 degrees west, let me draw in my north-south line. And that's going to be basically in this direction, right? Because I'm going to be 12 degrees west of my straight south direction. Okay, second boat I will do in green. This one is going to go north, 75 degrees east. That's going to kind of be off in this direction. Straight north would obviously be up, and 75 degrees to the west would be that direction. Okay, so I've got my boat A and boat B. They are going at different speeds. So the first one goes at 14 miles an hour. The second one goes at 10 miles per hour. However, my duration of my trip is 3 hours. That's in the word problem. So this is kind of a simple distance equals rate times time. If you went 14 miles per hour for 3 hours, this is going to be 42. And if you went 10 miles an hour for 3 hours, this is going to be 30, right? Okay, so those end up being lengths of a triangle. I'm going to kind of redraw my picture here off to the side. But I have a triangle where this length is 42, this length is 30, and the question is, what is this length? Let me do it in red. How far apart are the two boats? Okay, and from the angles involved in the picture there, I'm actually able to figure out this angle. Let me do it in maybe orange over here. This angle, okay, is really something I'm going to be able to figure out. And you might have to draw in also an east-west line to kind of help you see it. But basically I have an angle inside of here that's 90. And from the measurements given, 75. This tiny angle here is going to be 15. And my angle in question, I'll call it, let's just call it theta for an example, is going to be 12 degrees plus 90 degrees plus 15 degrees. And adding all those up, I think I get 117. So that is the angle in my picture. Voila, I have a side angle side triangle. And I should be able to then figure out the length of x, which is the word problem. I'll set it up for you. The rest is calculator stuff, but the x squared side is going to be 42 squared plus 30 squared minus 2 times 42 times 30 times the cosine of 117. Work it all out, button pushing on your calculator, and you end up with 61.7. Okay, my units in this problem were miles per hour, so I do want, since it's a word problem, to represent what that number stands for, and so those two boats are 61.7 miles apart. Alright, here's another example. Again, the picture is kind of key, so it might take a little time to come up with a picture for this. You are on a fishing boat that leaves its pier and heads east. Hard to read that, sorry about that. That says east. And you're going to do that for 25 miles. So I'm going to kind of start off here at point A. And I'm going to go straight east for 25 miles. Okay, at that point I am going to turn because of the weather conditions. And turn and go south 40 degrees west. Okay, so my turning point, I'm going to label that B, and my north-south line would be there, and I'm going to go 40 degrees west of that. So here's my 40 degrees west, and I'm going to go a little bit shorter distance, 13.5 miles, and the important angle there is 40. Okay, and when I stop my boat, I'm at what I'll call point C. And the question is, how far are you from the pier that you started with? And obviously that would be side X here. Okay, so in this one, I'm really just missing one piece of information, which is the angle inside the triangle. But if this is a straight east line and the other one is a north-south line, and that's 40, it should make pretty good sense that this is 50. And voila, once again, I have side angle side. And I have a formula for finding x. So x squared is going to be 25 squared plus 13.5 squared minus 2 times 25 times 13.5 times the cosine of angle 50. Put all that together, you get an x of about 19.3. Once again, we're in miles. Okay, there's a second part to this question, which is at what bearing could the boat have originally taken to arrive at this spot? So if I wanted to go straight from point A to point C, I would want to travel through this angle, right? So I'm going to call that theta and think about how I could find that. Well, it turns out if I can find the angle inside the triangle, I'm going to call that angle A, then I could find angle theta very easily by subtracting from 90. Think about that for a second. How on earth could you figure out angle A? Well, the good news is I have a law of sines problem. So sine of A equals sine of A over 13.5 equals sine of 50 over the side across from it, which is the answer to the previous part. And the math we can do on our calculator there, and I'll skip straight to the answer, which is that it's about 58 degrees approximately. Okay, now that's not my answer. Oh, you know what? Sorry, that answer is 32. About 32 degrees. And the angle that I'm looking for, theta, would be 90 minus that, and that turns out to be about 58 degrees. Okay, so we're going to practice these problems. They're a little bit tricky. The picture is a huge part of things, so you want to be able to do that. Here's one for you to try, though. Alright, so the big challenge here is coming up with a good picture. Hopefully you were able to piece that together. And probably the trickiest thing is the angle between the sides. And you have to use a little property of alternate interior angles you may or may not remember from your geometry classes. But when I think about these two angles, they should be congruent because they both touch the north-south line and share the diagonal there. And that angle in green there helps you come up with the actual angle I'm looking for, which is 108. So putting all that together, you should get about 800.